Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Hybrid Timber Buildings, Opportunities and Challenges. My name is Claire McMenamin and I will be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, WoodSolutions. WoodSolutions is a non-profit initiative established in 2010 to provide independent technical information on timber and wood products for building professionals. Supported by Forest and Wood Products Australia, FWPA, it offers comprehensive resources, including case studies, technical publications, and design guides to promote timber use in construction. WoodSolution also hosts seminars and workshops to foster sustainable and innovative building practices. Its mission is to help architects, engineers, and other professionals make informed decisions about timber, contributing to the growth and development of the design and build sector. Today we'll hear from our speaker, Nick Hewson, followed by an audience Q&A, and I really encourage you to send your questions through to our speaker via the chat box. I'd now like to introduce our first speaker for today, Nick Hewson. With over 18 years of experience in the construction industry, Nick is a chartered structural engineer and timber engineering expert. He has led diverse projects from domestic renovations to multi-billion-dollar civil and structural developments in the UK and Australia. As the director and founder of Arborelis and consultancy specialising in innovative timber solutions, he is passionate about promoting timber's role in a low-carbon future, and he has founded Timber Dialogue, a community organisation supporting timber use in Australian construction. Nick has a strong background in engineered wood products and structural dynamics and have contributed to multiple publications on timber design. Please join me in welcoming Nick Hewson.
Thanks for the introduction, Claire. As you said, my name is Nick Hewson. I'm speaking on behalf of WoodSolutions, and the topic today is hybrid timber buildings, opportunities and challenges. Just a quick little background about myself. Registered structural engineer with 20 years experience, largely focused around timber. Worked as a consulting structural engineer, as well as working for a materials supplier at XLAM at a prefab company in Sydney. And started my own company, Arborelis, about a year ago. So it's just a few snapshots of some of the pictures I've been involved in from the UK and in Australia. Just a quick outline of what we wanted to talk to today. As I said, speaking on behalf of WoodSolutions, so I just wanted to run a bit through who they are. We're going to do a little recap on engineered and mass timber, just to get a few of the terminologies correct. And then the bulk of the presentation is looking at what we'll talk about hybrid buildings and materials, and then a few case studies. If I start with WoodSolutions, some of you on the webinar may know already who they are, but they're a resource provided by Forest and Wood Products Australia. So they provide research, technical support, and promotional services, all focused around timber products. It's funded by FWPA members and the Australian government, and it's really designed to sort of try to make it easier for designers, specifiers to get the most sort of up-to-date and in-depth technical information they can. To that end, they've produced over 60 technical design guides focused on everything from sort of Class 1 housing and decking up to multi-storey buildings, looking at structure, fire, acoustics, costing, durability. So there's a huge wealth of information out there that's all available for free through their website. In addition, they have a project portal. So if you're looking for inspiration or more information on any of the buildings, some of which I'll show you today, you can head along to that link and see what projects are being done both in Australia and around the world. But when we're talking about timber, and we're talking about a sustainable, renewable resource, something that is natural, that stores carbon for the life of the building. And a lot of people aren't aware that up to half the dry weight of timber is carbon. So we have a material here that has huge potential to play a large role in combating climate change and the carbon footprint. There's also a number of studies coming out now that are talking about biophilia and wellness benefits of timber buildings. So we're really passionate about getting more and more timber into buildings to help both create healthier buildings and to decarbonise our existing and future building stock. So just a quick overview for those of you not familiar with engineered or mass timber. When we're talking around engineered timber, that refers to anything that is taking a tree, cutting it into smaller parts, and then putting it back together. So there are a range of different products in there, from things like plywood through to probably the big three, and we sort of talk around more often than not in buildings: cross-laminated timber or CLT, glue laminated timber or GLT, and LVL. So they're all created by, in the case of CLT and GLT, in cutting up logs into individual sticks of timber, then gluing them back, either in sort of cross layers to form CLT planks that create walls and floors, glue lam all aligned in the same direction to create beams and columns. An LVL is a sort of bit of a halfway house between the two. That's kind of like a jumbo plywood, or it's created by peeling logs into lamellas and making those back into billets, which can be used for beams, slabs, columns. So it's really these three products that have sort of captured the market in terms of mass timber buildings. So just looking at a little bit of the sort of hierarchy of construction carbon pyramid. So as you'll see, the timber products and engineered timber products like glue lam, very, very low carbon. If you include the sequestered carbon, which is the carbon that's locked into the structure as the tree grows, obviously through photosynthesis, trees take in carbon dioxide and produce oxygen. But that carbon that they produce through that process of photosynthesis is locked into the material for its lifetime. So very, very environmentally sustainable form of construction when compared to other forms like aluminium, steel, concrete, and the like. So this is just why we're focusing very hard on trying to get more timber into more buildings. So when we talk about mass timber, so I think the revolution's sort of been going on for maybe around a decade in Australia. So some of you may recognise some of the buildings on here. So we have, in Australia, we're probably really punching above our weight in mass timber. I think we were the one sort of second from the left on the top row is Forte. So that was the first really modern use of CLT in Australia. That was, for a while, that was the tallest mass timber building in the world. We have a host of other buildings on there which have gone on to achieve worldwide acclaim, and we've really kind of per capita, I think, probably got an extraordinary number of mass timber buildings up, and really have some world-leading examples. But if that was the last decade, then a lot of purist, fully timber buildings. What does the next decade look like? Increasingly, I think we're seeing timber, start to find its way into larger high-rise buildings, into different building typologies, and what we're sort of really passionate about is kind of normalizing timber so it becomes just another structural product that we can use, and it's got its advantages, it has its disadvantages, which we'll run through. But trying to take some of the more carbon-intensive materials out of high-rise construction, and start to substitute in timber where we can. So I'm talking about hybrids. I'm talking at a sort of both a sort of macro structural level, but a sort of building scale. That could be combinations of steel frame or concrete frames with timber floors or walls. Even looking at lightweight timber framing together with mass timber, which I think has some particular benefits, which we'll talk about later in the presentation. And then we're talking at a sort of more micro level of hybrid materials. So rather than looking at a building scale, we're looking at individual products, individual floors, walls, or beams. So that could be timber concrete composite floors or reinforced glulam and the like. So we'll cover both of those throughout the presentation. So I thought I'd break this down into some sort of combinations of materials, just to sort of show a few examples and sort of work through some of the key areas that we need to consider when we're designing. Steel and timber to me is always a kind of a good match. There's a couple of examples here. One which I was lucky enough to be involved on in Melbourne, which was a vertical extension on top of an existing building, which they achieved using steel frame and CLT floors. And that's in that case, the timber was chosen because it was a vertical extension. They needed something very, very lightweight. They needed the steel frame because the entire stability structure of the additional levels was all moment frames, because they couldn't really extend the core where it was. So the combination of materials there worked really well. On one of the rights, one that I really like as well, it's a building in London which uses a sort of cellular steel beams for services reticulation together with a CLT floor and core in that example. There's some slightly more left field examples. This is a building in New Zealand, in Nelson. So this is the Nelson Marlborough Institute of Technology, where they've actually been using steel post-tensioning cables. So that's there largely to help with seismic performance, but also what they've done there is used a sort of series of deflecting profiles to help the beam deflection and to reduce the amount of timber in there. So it's certainly there's an array of technology and different materials that are different ways of combining these, which are starting to under development. There's some really good research going on at University of New South Wales, where they're looking at technologies like steel beams and composite CLT. So at the moment, we don't really design our steel beams to take advantage of CLT floors and things when we put them on top, but actually we can find a significant degree of performance enhancement by doing that. Another technology that's also being researched is looking at reinforced glulam. So taking steel or carbon rods and bonding those into the glulam during the manufacturing process. That's got a number of advantages of improved strength and stiffness. A lot of this, it's about using the timber fiber more effectively. So we can use potentially lower grades of timber, which are kind of not very well utilized at the moment, potentially going into paper, packaging, that sort of stuff. So we can take a very low grade product and potentially, by using other materials like steel or carbon fiber reinforcing, we can then take those and turn them into a high grade product. So just looking through some of the pros and cons of those. So I always find that steel and timber works very well together. They're both they're both dry trades. We're not reliant on backpropping like we might be with concrete. Tolerances are very similar. The construction language is very similar. So you've got the same subcontractor that's potentially installing both the steel and the timber together, making for a far easier kind of coordination on site. Some of the challenges, getting that coordination ready between the two separate suppliers is difficult. Having enough tolerance designed into those connections, making sure that we don't need to go cutting and welding timber on site is a challenge. Compliance, particularly for fire, is less well covered. Any combinations of materials when we're talking about fire testing, tested solutions and things is a challenge. So that's something that suppliers can assist with, but it bears kind of particular kind of focus at the start of a project to make sure that you have all those areas covered. Concrete and timber. Typically, you find a lot of interfaces between concrete and timber, even on a sort of more purist mass timber project. There will often be a timber ground floor or suspended transfer slab. You may have a concrete core for fire reasons or for structural stability. But often what we see is what we call timber concrete composites. So that's often either a CLT floor or glulam floor with a kind of concrete topping. We'll talk a little bit more about that in a second. But there's a number of examples around the country that have used that sort of construction language and technology, and it's certainly got some strong advantages. So when we talk timber concrete composites, it essentially kind of works by forming a sort of shear connection between the concrete and the timber, so that the concrete's working where it works best in compression, and the timber's forming the tension element. So there's a number of different ways that can be achieved through notches, plates, or screws. There are proprietary systems. There are that are available. There are there's potential to design these from scratch. There are design guides available. Some of those through WoodSolutions if you want to take a look. And these have a lot of advantages, which we'll dig into in a couple of slides' time. One thing I will highlight now is that moisture element. So anything that involves a kind of wet trade together with the timber needs to be very carefully managed. And you'll see from the image on the right-hand side that they've got a layer there to avoid the moisture transfer between the two. Works both ways. So you don't want the timber to get too wet because timber doesn't like to get wet. You also don't want to kind of draw the moisture out of the concrete because the concrete won't cure properly. So getting those systems right is really critical to make sure that the building is going to perform. But one system which is just sort of coming on the market now is from a company called ASH, or is short for Australian Sustainable Hardwoods. So they have what they call their Advanced Timber Composite Floor, ATC, which is a combination of Victorian ash glulam, a plywood sheet, and then a cast-on-site concrete topping. So we're looking at that on a few projects at the moment, where we're looking to expose the timber beneath and have a kind of solid, robust system that's high performing for fire and acoustics. And then there are even other ones. There's the Peco Delta Beam system together with timber concrete composite floors, which I'll show from a project example a bit later in the presentation. This is a sort of integral steel beam which forms a permanent formwork for your beam through your concrete slab. They work together with the sort of timber bottom layer and then cast concrete through the whole thing. So it's one of the strong advantages of this is that it creates a almost completely flat soffit. So you don't have downstand beams, which you might do with a steel or a timber frame building, which makes service coordination a whole lot simpler and has a sort of strong advantage there. So why put things together with concrete? The concrete does have a lot of benefits. So particularly when it comes to fire, acoustics, floor vibration, timber is a lightweight material, so it doesn't have a lot of acoustic performance, doesn't have a lot of damping in it. So in a number of cases, concrete often performs a strong service there in improving that performance. It also kind of gives you a natural diaphragm on top of your floor, which can make connections and design a lot simpler. Some of the disadvantages, it makes the building heavier. So if the timber is often chosen for its lightweight nature, so that's obviously kind of working against that. As I said before, that moisture control element is very challenging to manage. So that needs to be a big focus from the start. The challenges around fire stopping and interfaces is another. Bringing in that sort of wet trade, having to back prop, things like that can add to the construction controls needed. So there are some strong benefits, but some challenges to be overcome. So it's up to engineers to look at those on an individual project by project basis to make the best choices there. Something that we've seen start to crop up as we put timber into taller and taller buildings is what we sort of call a mega structure. So this is the Lyceum Tower, which you may be familiar with, which is under construction in Sydney. So what they're doing on this one is creating a number of mass timber habitats within a sort of more conventional steel and concrete superstructure. The reason they're doing this, largely to help, decarbonize their building. They had some pretty lofty goals in terms of embodied carbon for the structure. So they were looking to get timber in there wherever possible. And they've kind of done this by effectively creating, these mega floors. So those sort of floors that you see in red are substantial steel and concrete floors, with the sort of blue zones being the timber zone. So those individual buildings are effectively kind of 3 to 4 stories of timber sitting on a shelf. So that has a number of advantages for a building of this height, and it's you're not bumping up against capacity issues or the sizes of columns and things blowing out for a pure timber structure. The stability loads are resisted by the core, so you're not worried about the timber there. So it's really just supporting itself over 3 stories. So the timber becomes kind of a lot simpler there. And one other huge advantage of this sort of form of construction is it's creating a kind of a natural fire break. So one issue that we talk about in timber is fire spread, and that's something that's a long way because this goes a long way towards mitigating that. So if if a fire breaks out in a timber compartment and can't be contained, it's limited to those sort of 4 floors, and we can still maintain the stability and evacuate the rest of the building safely. Some of the challenges for a system like that would be, this particular case, those red floors are built before the timber ones, so the actual kind of construction methodology is quite limited. You don't have a lot of space to operate cranes within those floors, so the actual methodology becomes challenging. There's a lot of different materials to coordinate, and also looking at the differential movement between the superstructure and the timber floors, and managing how those elements interact, and as the structure is built continuously and things move, trying to make sure that we've covered tolerances and things is a challenge. This is one I've got a particular personal passion about, which is a sort of hybrid of mass timber and lightweight frame. There's a good example in Sydney, the Phoenix Apartments, which is 6 floors of lightweight LVL prefab walls together with CLT floors. So increasingly see this as an option for that sort of low to mid-rise housing, social housing, and we'll see some examples again. But it sort of captures a lot of the benefits of CLT, along with some of the economic kind of cost-effective solutions like pre-clad LVL walls. This is really kind of taking off in the USA. So it's highly cost-effective for that sort of up to 5-6 stories apartments. The CLT floors are relatively cost effective, so they provide a kind of a very fast element for your floors. They have a high level of natural fire performance, and they give you a kind of solid base at each level, making those sort of junctions between units a lot easier. Timber frame walls, on the other hand, are going to be a whole lot more cost effective than a CLT wall, particularly at that sort of height. You only need to kind of think about a traditional timber frame wall, and may have 90mm studs at 600 centers. When you compare that to a 90mm CLT wall, you can you can see how much additional fibre is kind of getting used in those walls compared to what you may need for a lightweight structural frame. So we have a lot of opportunity in that sort of missing middle, small apartments, townhouses, and things for this sort of form of construction. Some of the challenges there are the level of prefabrication that you can get in those walls is varies around the country. Some fabricators are doing sort of fully pre-clad, closed-in walls. Other areas of the country may have less capability or capacity. So, if you're looking at this form of construction, I advise you to get out and speak to your local timber frame suppliers and see what sort of options and capability they have. There's that coordination piece between the two suppliers, which is still kind of challenging. And then the additional fire and acoustic performance is still going to need layers of plasterboard and finishes to be added. I put this in because I think this is again another kind of option for particularly multi-res buildings up to sort of 15 stories high. So this is what we call post and plate. So this is a combination of columns and CLT floors. So utilizing a thicker CLT floor that spans in two directions between point supported columns. So what this is doing is it's eliminating those beams, which can be both expensive and also difficult to coordinate around. And we're seeing a lot of development in the US around this space. So this is kind of where they're moving to now, the sort of hybrid of steel and timber. So utilizing steel columns because they're able to be sort of fabricated and have these column capitals as well as they're thinner. This one particularly has got steel frame brace cores as well. This has been a game changer in the US, and there are an absolute hatful of projects that are starting to utilize this system. It creates a forest of columns, but it creates a lot more flexibility. You're not using expensive materials like CLT for your walls. So this is something that we're going to see more of in Australia in the next few years. I just wanted to run through a few case studies that I've been lucky enough to work on, which have a sort of number of different materials. This one is for a college in New South Wales. This is their Innovation and Science Centre, so quite a lot of kind of lab and workshop spaces as well as some teaching spaces. So this one was tendered as a timber building above ground. That's sort of those two suspended floors on the roof. They were built from CLT and glulam, and then they had a sort of concrete framed lower ground story there as well. So the company I worked for previously won this one, and what our solution was, and I'll tell you how successful this was at the end, but we had a number of different systems. We had CLT walls, we had glulam beams from two different suppliers, we had lightweight prefabricated LVL walls, we had a timber concrete composite floor, we had steel frame, we had delta beam, roof trusses. So pretty well every system that we had available to us was thrown at this. And the only way this was possible was through that sort of single supplier. Trying to coordinate, for a builder or someone trying to coordinate across all these materials themselves would have been an absolute nightmare. This is just a picture from site showing some of the different materials. We had steel frames, braced cores. We've got two different glulam suppliers there. We've got the timber concrete composite floor going up in the background. So this one we had three separate suppliers, as I said, for the mass timber. We had GL18 Vic Ash glulam columns on the ground floor, chosen for durability reasons. We had internal spruce beams and columns from Hauslacker in Austria, as well as CLT radiator pine from Exlam in Australia. So a real kind of mishmash of materials in there. We had a timber concrete composite floor, which was designed by my previous business, which is a combination of glulam, sort of steel troughs and channels, and an in situ cast topping. So this was designed to be capable of spanning up to 9 meters with no backpropping, to give you that that timber soffit that you can see from below, but as well as that kind of that concrete solidity that you feel on the top. We also used delta beam for areas of the floor as well. So I showed this earlier, but this is a sort of was used for that services coordination. So you can see in the photo that we had some areas of glulam beams which were downstands. They had a few holes through them for services coordination, and then through the center of the building we used the delta beam, and then that was your sort of services superhighway basically. So all the main ductwork and things went down that corridor under a drop ceiling and then peeled into the classroom. So it really kind of gave us a lot more flexibility in how we service the building. This was the timber concrete composite floor going in on site. One of the challenges and lessons learned here was around moisture control. There's a significant amount of rain around Sydney at this time as we're building this, and managing where the water went before the concrete was poured was extremely challenging. It's something that we need to focus on a lot throughout these projects. The roof cassettes were much more kind of domestic style, so just utilizing 90 by 45 timber roof cassettes, so built out of traditional trusses. And these were all fabricated into up to sort of 12 by 3 meter modules and then dropped into site, just spanning between the glulam frame. Very, very cost-effective way of forming the roof. And then prefabricated LVL walls for those non-structural components. We left off the internal linings of those so that they could come and do the cladding, the internal linings and electrical work. But we've been able to integrate services into those and other projects. So some of the positive outcomes out of that one, that early supplier engagement meant that we could really lead the design and provide that coordination element between the different suppliers. So given that some of the material was arriving from overseas and had a significant lead time, there was no way of really achieving that. Otherwise, if we'd gone down a traditional path, it would have been another 6 months potentially before the building was delivered. And always being able to pick from the right, the different materials we had on offer, and you could always sort of choose the more cost-effective option. Some of the lessons learned. The flip side of the last argument is that the procurement piece was challenging, because we had those long lead time elements, some of the materials coming from Europe, those elements got designed first and then had to be imported. So we were still kind of continuing with design on some of the other elements as we went. So we sort of had to fit those around the decisions we've made earlier in the process. Some of those would have been potentially made differently if we had the chance again, but trying to get that full design complete before you go out on all elements before you go out to suppliers would be an ideal way to do it if you can manage it with the time frame. Design resources were significantly higher than we hoped. Took a lot more coordination than maybe we expected. Moisture protection, as I mentioned, was a large challenge through that combination of concrete and timber. That's something we would have concentrated on more in future projects. And also tolerance. The different materials, how they meet each other, and how we sort of get those to work is a large challenge. And in retrospect, maybe we could have thrown a few less systems at it to make that coordination piece a bit easier. The next project I wanted to share was some defence housing. The total of 9 two-storey modules and 2 single-storey modules. This was a project delivered using lightweight timber framing, some steel beams and screw piles for foundations, prefabricated LVL walls and roof cassette, and a CLT midfloor. The reason I kind of want to show you this one is just to highlight just how cost effective this sort of combination of lightweight and mass timber can be, particularly for low-rise construction. This was a large kind of amount of coordination, particularly as you have nine modules all the same. So that design time is well worth spending a lot of time resolving every last detail and junction. So that when you repeat it across 9 buildings, that you're building something very, very efficient. So the LVL walls on this one were pre-lined internally and clad externally. Insulation and windows were installed, and then the whole thing was delivered on this sort of toaster rack transport modules. Floors and roof cassettes were both sort of LVL framed, pre-insulated or roof sheeted or floored with FC sheet, supported on steel beams at the ground level. So you'll notice the sort of timber packers that were put on top of the steel beams. So one of the biggest challenges that we find with the foundations was working out exactly how to install these quickly and efficiently without having to kind of work under the cassettes and fix up through steel flanges. So we developed a system of timber bearing plates on top, pre-installed to the steel, that we could screw from the side or from the top, so we didn't have to access underneath. And this was one of the most remarkably stress-free installs that we've ever had to work on. Working on a live army base meant that it was very beneficial to have few people on site. So this off-site modular construction methodology made so much sense for this particular project, because every employee was vetted and had to go through security checks and things. So keeping that sort of to a minimum was critical. But the construction on this was way faster than anyone even anticipated. It was very, very successful, both from an install and from a manufacturing perspective. That combination of the CLT mid-floor worked really, really well. Very, very fast to install, just in half a day, and provides that sort of baseline of fire and acoustic performance. And the builder said afterwards, it's one of the most cost-effective ways that they could ever have delivered that, including kind of volumetric modules. So it was hugely successful. It's probably not going to win many architectural awards, but the outcome was exactly what the client was looking for. The builder was blown away by how fast and easy and cost-effective it was when they compared it with other systems. Some of the things we may do differently next time. I think that ground floor cassette may have been even more efficient in CLT. Definitely that early engagement with the supply chain was critical to this. And then there's further capacity, to optimize this through pre-installation of services and things. So winding up now. So why have we been talking about hybrids? So, as I said at the start, that reduction in embodied carbon in buildings through the wider adoption of timber. Should we be trying to use more timber in more buildings rather than build one purist sort of fully timber building? I'd love to see more use of timber, particularly in those sort of high-rise areas, to help offset some of the heavy carbon materials in those. But being realistic, so using timber where it works, but using other materials and other systems where we need them, whether that's structural capacity or fire performance, not being afraid to combine those or utilize the right material for the right job. And using timber and using hybrids to get into buildings that otherwise maybe wouldn't support a fully timber solution. And then also to celebrate the aesthetics of timber while we, for what it is. So, getting capacity to expose those details through the addition of other materials like concrete to supplement acoustical fire performance, so that we can really celebrate the material where it's best suited. So some of the barriers. Coordination risk is a big challenge. So the more materials you add in, the more interfaces and the more opportunity for errors. We've seen that on some of the examples that I worked through. So establishing those tolerance matrices early. Which element is going to be your sort of skeleton that you build around? Is it the steel? Is it the timber? Is it the concrete? So where do those different materials meet? How do you deal with their different properties for fire and acoustics and things? What do those junctions look like? There are a lot of solutions out there. So engaging with particularly the timber supply chain who can provide that information. The procurement risk. I think we're seeing more and more suppliers and fabricators start to be able to offer these additional services, whether it's supplying steelwork or blue am or CLT, or in the cases of ash, providing their flooring solutions. So suppliers and manufacturers understand this and are starting to offer more and more solutions. So again, encourage everyone to get out and engage with that supply chain. And then on the design side, that level of coordination required between those can be heavier. So we've got to allow sufficient design time and coordination prior to fabrication to make those savings in time on site. So encouraging clients and engineers and designers to really hone in on those fine details and interfaces. So summarising, we want to see a reduction in embodied carbon in buildings through encouraging wider adoption of timber. Choose the right material for the right job. Just because you can make it timber doesn't mean it should. We should always be looking to optimise for the right solutions, and don't be afraid to mix things up to come up with something cost effective. Engage that supply chain early, particularly the timber supply chain is ever changing. They're always offering new solutions and services, so keeping up to date with their capacity and capability is critical. Making sure that we manage those interfaces between the materials, looking for particularly fire compliance tolerances and moisture management. So we look after those, then you're going to have a much more successful hybrid timber building. So thank you. Thank you on behalf of Engineers Australia and WoodSolutions for the opportunity to talk today. There's some contact details there for myself and for WoodSolutions, and a short plug for Timber Dialogue, which is a community I help run, which looks to provide information for people who are passionate about timber design to come together and share learnings and help to push forward the timber industry. So please come and join that, and join in our webinars and discussion forums if you're interested in learning more. So thank you very much.
Thank you, Nick, for your presentation. So it's now your turn to our audience to get involved in the Q&A. So please feel free to ask your questions in the chat box, and we'll kick off with some that have come through registration and bring Nick into the conversation. So thank you, Nick. I'll kick off with the first question from John in Queensland. So John asks, how do we convince clients and builders to use timber in their projects? That'd be a nice one to start off with.
Yeah, I think there are probably two main areas that I'd look to do there. One is looking at the benefits. I think one of the biggest benefits is around that embodied carbon story, and reducing the impact of our buildings. As we sort of spoke about earlier in the presentation, timber takes in carbon as it grows. So by using more timber in our projects, we're helping to address climate change and the like. So that's one kind of big benefit. Another one that we're seeing increasingly more research around is what we call biophilia. So humans kind of have a natural affinity with materials like timber. part of a study that's going on at the moment, looking to monitor people in a timber office building and compare them with their sort of stress sort of markers and compare between a timber office and a kind of more conventional plasterboard clad office. So there's some interesting early results out of there showing that people are kind of calmer. They're more productive in timber buildings. So I think there's a good positive story there. Then on the other side, it's about kind of taking some of the sort of common myths around fire, around durability, around all those questions that automatically come up when you start talking about timber. We have a lot of solutions for those. We've built these buildings, for the last 10 years in Australia. So it's about kind of giving the market a level of confidence in the material and the product.
Perfect. Thanks, Nick. And we've had a question from Andrew in New South Wales. Is there a sweet spot for timber to maximise passive sustainability and minimise construction time?
I think certainly the some of the examples that I showed today, I think where it really works well is in that sort of low to mid-rise space, whether that's housing, whether that's schools or education buildings, really any client that's sort of looking to decarbonize. I think specifically in the housing space, I get a lot of clients sort of coming to me looking to build CLT domestic houses. So when I get a client like that, I sort of say, look, for a domestic house, something like CLT is going to be a premium solution. So, what are your drivers there? Is it sustainability? Is it kind of things like air tightness or speed on site? There are some things that you can do with CLT around sort of some more gymnastics around structural design and getting kind of cantilevers and things. So if someone's sort of looking in that domestic house space for CLT, there needs to be some driver other than cost, because it's naturally going to cost more than a stick frame timber house or something else. So in that sort of low rise space, that's why we're sort of turning more towards sort of hybrids, where we're using kind of lightweight framing together with mass timber as well to get the most bang for your buck and use that timber fibre most effectively.
Thanks, Nick. It's nice to be able to use both the products to really maximise the project as well. We've had a question from Ying in Victoria who's asked, what's the main difference between hybrid timber building and traditional timber building?
I think so. When we're talking kind of hybrids, and I think the term can be applied fairly loosely, but what my kind of passion and driver is, it's about kind of normalizing timber, particularly once you get out of that domestic scale into more sort of schools and commercial buildings. So it doesn't have to be a timber building. It's not a kind of purist structure. Having the confidence to be able to specify the right material for the right job, and use timber where it makes the most sense, and not try to push it into every single system, cores, walls, floors, for everything. We're going to get more timber. We're going to use more overall if we use it effectively in the right areas. We don't have a kind of enormous surplus. We're not going to turn around and start building every single building out of timber tomorrow. But if we can use it effectively in the right places, then we're going a long way towards becoming just a normal part of construction, and just a material that we don't need to treat as sort of special or somehow kind of difficult or unusual. Like it just needs to get to a point where we're all confident using it where it makes sense.
Thanks, Nick. And a question here from the chat box from one of our audience members. So Sunda has asked, who will drive the adoption of hybrid timber buildings? Will it be government or industry?
It's definitely it's an interesting question, and I think seeing a number of key clients that are driving this. I think you look back through the last decade in Australia, a lot of universities and educational tertiary education have really pushed timber hard. For those kind of biophilic benefits, for the speed of construction, particularly schools and universities building on campuses and in school grounds, trying to minimise construction disruption, that sort of thing. So certainly seeing a kind of a strong demand in that education sector. In that kind of government space, there are certain kind of governments, local and state sort of governments who have timber encouragement policies, and they're looking to generate demand for timber buildings across all sort of civic and social buildings as well. So I think I see a combination of that, but it's really something that we as designers, as engineers, that we need to be putting forward as well. We need to be one of the ones driving this change as well, and challenging clients to look at timber in a new way, and to espouse the benefits.
Absolutely, thank you. Another question from the chat box that's come through from Eng. So, how does the system perform as a composite structural element in terms of bonding between timber and concrete?
So I think the sort of timber concrete composites is something that I've actually sort of been quite passionate about for a while. Like, we sort of did a number of buildings back in the UK using this sort of technology, and there's been a few examples in Australia. It's about kind of creating that sort of sheer connection between the concrete and the timber, and there are a number of different ways to do that, whether it's the notches or screws or plates. I did a bunch of testing for a job for Melbourne Uni a number of years ago, which demonstrated that the timber notches actually perform really, really well. Very high capacity, very robust. But there's a heap of design guides out there and technical information which sort of give you capacities and stiffnesses for those interfaces, because you naturally kind of generate some sort of loss, some sort of slip in those. So picking the right connections is important. There's some design guides on the WoodSolutions website. If you log in there, and there's a design guide on timber concrete composite floors that's available there, and gives you a lot more kind of design information. And if you want to know more, some of the suppliers of the screws, of the plates and things, can provide more technical information on those.
Thank you. And that probably leads into this question as well from Craig in Queensland. So, with the use of light prefab structures, do you need skilled or specific site assistance to construct these structures?
It's certainly a huge benefit to have an experienced team. It's not always totally necessary, but there's a number of specialised installers that work across most states now. There's likes of Stanstruct or Savcon, Excel, that sort of work up and down the eastern seaboard, Oriel, those sorts of guys. There's Constructive PD over in WA. So having an experienced team that understand the material, how the connections work and things, is often really beneficial to the project. I've certainly have seen green teams do this. It's not something that I would necessarily recommend on a large scale project, but certainly for smaller scale buildings, it's possible. What really kind of the experienced installers really come into their own on those larger projects where where the construction period is really critical. Getting things installed quickly, like there's a kind of very specific kind of choreographed dance when you're installing these. It's all about hook time. It's all about getting the materials into position, getting them locked in, and getting that crane moving to go pick up the next piece as quickly as you can. So there are ways and connections and ways of detailing structures to make that happen quickly. And the good installers are able to use their experience to help drive that design, particularly if they can get on early. So I'd always recommend speaking to an experienced installer and getting their advice if you can. It's invaluable in driving a kind of design for manufacture and assembly approach, and really sort of making things efficient on site, particularly understanding things like moisture management and visual panels and things like that as well is a massive kind of learning that a lot of these guys have gone through. So certainly would recommend it, but possible to do on smaller projects.
Okay, thank you. And I've got two questions that I'll share together. So this has come in from Alan in New South Wales. Do you have any case studies of in-service glued laminated elements in operational structures, and what has been their durability outcomes? And Liang has also asked, in Victoria, are hybrid timber durable? So they might be nice for you to answer together.
I think, look, the biggest enemy for timber, well, two in Australia really is termites and water. I would sort of say that we tended to detail pretty well for termites on a lot of the projects that we've done in the last decade. We're using larger mass timber structures, so by separating from the ground, leaving living inspection zones for termite inspections or treating timber. Both Australian CLT suppliers and the major glue lamp suppliers can all offer treated timber. It's pretty common these days, and that's a really good fail-safe there. Often we'll find that the timber structures are separated from the ground anyway by kind of concrete slabs or a podium transfer level in larger structures. So that one's sort of been well dealt with. What probably hasn't been well dealt with is moisture. This is definitely an area where there's a lot of new research, a lot of new products coming out, a lot of new thinking. So for any timber structure, whether it's a sort of pure timber structure or a hybrid, we're advocating for sort of like same way that you would do a moisture and a safety and design sort of process. We're encouraging designers to sort of take a moisture and design process. So from architects through engineers through builders and installers to really consider how you're protecting your timber, particularly high risk areas, balconies, roofs, wet areas, that sort of thing. So allowing for multiple points of protection. So if you're you're trying to kind of build a timber bathroom potentially, allowing for a membrane to fail effectively. They're seldom going to be 100% effective. So you always need to ask yourself, where does the water go if the membrane fails, and trying to allow for drainage and overflows and things is going to be absolutely critical. In terms of durability of glue lam, like there are glue lam structures that have been around for over 100 years. So it's not a it's a very durable product. The sort of engineered products if they're well looked after and maintained.
Thank you. And a question from Nathan in the chat box today. Is there a control measure on moisture effect on timber foundation, a one-time effort or done at intervals? And how is it done and what's involved?
I think again, going back to this sort of the topic of moisture, we're always trying to design out places where moisture can collect. Foundations, for instance, would always be trying to pick timber off up the ground. There are sort of some basic principles for timber design. To put simply, it needs a good hat, coat, and boots. So we need to protect it from the rain above, and we need to protect it from moisture from below. So that can be picking it up at the ground on steel or concrete, or suitably kind of durable hardwoods potentially, and allowing for protection measures, whether that's sort of coatings or paint on treatments, that sort of thing. But it's an ongoing process, so we need to be allowing to maintain and inspect these buildings over years to come to make sure that they're operating, and that the timber's still being able to be kept dry and avoid any potential long-term damage.
Thanks, Nick. And we are sadly getting out of time for today. I just might throw to you just about what you'd like the audience to take away with them from today's session.
I think what I'd like to sort of, just re-emphasize is that, timber, it's a glorious material. If you'd asked me, did I expect to be involved in timber buildings when I came out of university? I didn't. It was something that kind of fell into almost sort of by accident, and I've discovered a real passion for it. The more I get involved, the more I kind of understand around the process and the material, the more I kind of learn to love it. I think it's definitely something not to be frightened of. There are plenty of good examples built across Australia. There's great design guides and resources. We're lucky in Australia that we've got some exceptional local suppliers for both mass timber and lightweight framing. So I encourage everyone to get out to learn more about those and to engage with resources like WoodSolutions to continue to learn more.
Thanks, Nick. And that is all that we do have time for today. So please join me in thanking Nick for his time today. I would like to thank Engineers Australia's industry partner, WoodSolutions, for their support. I'm also very excited to share that Engineers Australia's 2024 Climate Smart Conference is being held tomorrow in Brisbane. Please follow the QR code on your screen. We are still taking some registrations. Don't also forget to look out for our 2025 Engineering Excellence Awards. The registrations and dinners are being held across Australia celebrating engineering excellence. If you don't mind, please completing a short feedback form linked in the description box. We're always looking at ways we can improve and plan for future sessions. And thank you again for joining us today. We hope you found this session really valuable and look forward to seeing you at the next Thought Leaders event.